Hi, everyone. My name is Rachael Rowe, and today I would like to invite everyone in this room to be vulnerable with me for the next few minutes. Now, I know that might sound intimidating, but I believe I have something meaningful that I would love to share with you all. So let's look inward for a second. Can everyone think of a specific time in their life where they were met with an immediate amount of overwhelming stress? Maybe this was a car accident, an injury, a job loss. It doesn't matter the circumstance. You were left feeling shocked and completely out of control. Now, I apologize for making you think of this time, but stick with me. Because now, can you think of another instance where the stress, although impactful, still lingered afterwards, like a weight you couldn't shake? Maybe this time that was prolonged bullying or grief or even ongoing financial struggle. If you're anything like me, those two things were the same. When I was 20 years old, I was a victim of sexual violence. And that event was horrific and sudden and deeply confusing. And in the months that followed, so did my stress. Anxiety, depression, PTSD, OCD. Think of a symptom, I had it. And it also felt like, although his hands were no longer on me, I was under his control or something's control because my body no longer felt like my own. And I felt like I would be stuck with the trauma that I had endured for the rest of my life. But I'm here today with you all, with more confidence and compassion in myself than I ever thought possible. And I know that this might sound funny, but I owe it to one thing: neuroscience. For me, it was what about my stress response could I control? And what about it on a physiological, psychological, or even genetic level could I not control? But before we get into all of that, why don't we start at the very beginning? What is stress? Stress is a psychological and physiological response to a perceived threat, and it can be categorized as either acute or chronic. Acute stress is our body's immediate reaction to a perceived stimulus. Think an exam or me right now. So, past research has shown that when in bursts, acute stress is actually beneficial. As it aids for neuroplasticity, it allows us to perform under pressure, to stay focused. And once a stressor occurs, our sympathetic nervous system triggers our fight or flight response. So our heartbeat rises, our airways expand, our senses heighten, all of that necessary for survival. And once that stressor passes, our body goes back to a baseline, or what I like to call homeostasis. However, if a stress is large enough or if it persists long enough, well, then we encounter chronic stress. And that is when our body's natural mechanisms to deal with stress become maladaptive, as our stress response goes far past once the stressor was even present. So what circuitry naturally governs our stress response? It is the hypothalamic pituitary adrenal axis. And since I do not have you all day, we'll call it the HPA for short. So let's go through it together. It all begins at the hypothalamus, which is like the control center of the brain. And what happens is fear signals from the prefrontal cortex, from the amygdala, from the hippocampus start there. And they send these fear signals to the hypothalamus to trigger it to release CRH, a messenger hormone. This messenger hormone then goes to the pituitary gland, allowing that to secrete ACTH. Once ACTH is in our bloodstream, it then goes to the adrenal glands that sit right on top of the kidney. And from there, we get our stress response hormone, cortisol. Cortisol then goes throughout our body, and we get our fight or flight, our fear response. But like everything in nature, we need a balancing act, something to turn off our fear response once that stressor is gone. This is done with the negative feedback loop. So once a stressor has passed, the leftover cortisol actually binds back onto the hypothalamus, onto the pituitary gland, onto our initiating brain regions, telling them to no longer send fear signals to the hypothalamus and to no longer create cortisol. This is what turns off our natural stress response. But when it comes to acute stress becoming chronic, there are two main reasons why this happens. One, a hyperactive HPA axis, and two, actual physiological brain changes. So chronic stress produces an overproduction of cortisol, and it causes the HPA axis to stay on. So our initiating brain regions become less sensitive to the negative feedback loop off switch. It becomes less sensitive to the negative feedback loop's message to stop our stress response. And this constant cortisol causes the prefrontal cortex to have issues with decision-making and emotional regulation. Our amygdala becomes hyperactive. We get a greater fear response. And the hippocampus actually physically atrophies. So we have issues with memory and learning. So let's think of it with a main idea. If the HPA axis is our main circuit board, diverting signals of fear throughout our body, and we can think of the negative feedback loop as our on and off switch, well, we need a technician. We need a specific regulator whose job is to oversee and maintain this beautiful circuit. That job is for the microglia. So microglia are the resident immune cells of the brain, and they play a role by clearing signs of pathogen, foreign bodies, inflammation, and debris. And they do this by always being on a spectrum of activity that can be represented by their shape. This is an example of a ramified or resting microglia. So in this state, you can see that there are arms called branches that are used to scour the environment. In this state, these cells are anti-inflammatory, as they have mechanisms to suppress neuroinflammation. However, this is an example of an activated or amoeboid microglia. In this state, these cells are pro-inflammatory. Through a mechanism called phagocytosis, resting microglia get activated and engulf and break down foreign bodies or pathogens. In this way, they then activate other microglia, causing a pro-inflammatory defense mechanism. However, stress itself is a form of inflammation. So in a chronic stress model, constant cortisol causes microglia to be stuck in this pro-inflammatory state, to be stuck on. So we end up with a very vicious cycle where constant stress, chronic stress, naturally causes cortisol release. But then the constant cortisol impairs our initiating brain regions, making them less sensitive to our off switch, making them less sensitive to the negative feedback loop. It no longer works. But this continues the HPA axis, driving more and more cortisol production. But then our brain is now neuroinflammatory, activating our resting microglia and making them activated and amoeboid in shape. But if our brain is inflamed, then that sends more signals to our initiating brain region, triggering to continue this response. This is what happens under chronic stress. This is the pathway that gets maladaptive and that gets dysfunctional. So think about it this way. If stress can rewire our brain like that, what can it do to our ancestry? Can the effects of chronic stress ripple across generations? It can, through epigenetic inheritance. So past research has shown that a stress response in a mother can actually be passed down to the offspring. And in my lab, the most important type of stressor to us is a high-fat diet, specifically a maternal high-fat diet. So in both a human and a rat model, a mother exposed to a high-fat diet can give their offspring a sort of baseline standard of neuroinflammation, a standard of high cortisol production. So the offspring inherit this constant chronic stress maladaptive pathway. So in the mother, when they undergo a high-fat diet, they have gene modification, an altered stress response, and they also have reduced maternal care. And the offspring, they change because of two ways. One, the passed down cycle from their mother, and two, because of their experience with the reduced amount of maternal care. So they can have disruptions to their dopamine and serotonin. They can have a baseline of anxiety and depression, and they can also have cognitive deficits or impairments. To me, learning this was so incredibly freeing because it meant that not only did I always have the mechanisms to bring me back to a baseline, but it also meant that when it came to my trauma, the feelings and changes that I experienced could have been modifications that were already there. To me, it meant that my body wasn't broken. It was trying to heal and protect me in the ways that it knew how, with the tools that it had at hand, and it was trying its very best. So in my own research, I'm trying to understand, can I reset neuroinflammation caused by a maternal high-fat diet? Can I reset this in both the mother and the offspring? And I do this with a drug called clondronate. So clondronate actually depletes microglia. It kills them when it is targeted. So I actually surgically target microglia into the amygdala, remember the fear section of our HPA axis, in rats exposed to a high-fat diet and in mothers exposed to a high-fat diet. And what my very early data has shown that not only does it kill microglia when administered, but it also reduces microglia activation. And the microglia that are left over look more like a resting and ramified microglia than an activated one. That means that if we were to somehow target microglia depletion, maybe we can reverse or mitigate the effects of chronic stress, the effects of neuroinflammation caused by a maternal high-fat diet in both the mother and the offspring. So let's go back to our original thought experiment. When you think of your most stressful times, when your heartbeat is in your ears, when you have a pit in your stomach, does it feel less scary now? To know what's happening, to know how you feel these ways, and to also know that not just you, but your mother, your grandma, that everyone in this room has felt the same way you do. And to also know that you've always had the tools to bring yourself back to a baseline, because you have every single time. Life is hard, Stress is inevitable. We can't imagine a world without stress, because to remove stress would be to remove the adaptation, evolution, and resilience that it took to get you here today. So stress, although scary, although deeply uncomfortable, it's a connection to your ancestry. It's not your enemy. It's a reminder of all that you have and all that you will overcome. Thank you so much.